Fourth grade into math lesson 14.6. Add fractional parts of 10 and 100. I can rename fractions with denominators of 10 and 100, so both have denominators of 100. I can add the fractions. So, like we were just talking about, in order to add or subtract fractions, you have to have a what? Common denominator. If you don't, then you have to find one first, and then you can go ahead and go. If you do already have common denominator, then you can go ahead and start, correct? Yeah. Okay. Step it out. Number 1, a cook measures the mass of salt and puts it in a bowl. Then she measures the mass of pepper and puts it in the same bowl. What is the mass of the salt and pepper mixture? Okay, so do we have a common denominator there? No, one has 4/10 and the other has what? 2,500. So can we just go ahead and add those together? No, we cannot. We have to find a common denominator first. So a common denominator is a denominator that 2 or more fractions share. You can add 2 fractions if they have the same denominator. When fractions have the same denominator, they have a common denominator. The fractions 4/10 and 2,500 do not have a common denominator. But can we find a common denominator for them? Yes. Yes. Okay. Are we going to have to change both of them? No, just one. Okay. And even though we change the fraction, is it still an equivalent fraction to what we started with? Yes. Okay, it just has a new denominator. So they said to get from 10 to 100, you had to take it times what? Times 10. So what I do on the bottom, I also do on the top. So what is 10 times 4? 40. Okay, so now do I have a common denominator? Yes. What is my new common denominator? 100, right? So I changed 4/10 into 40/100. And then what was my original fraction for the other one? 2,500. So what is 40 plus 25? 6,500. Now, if I needed to simplify, could I? Yes, but they're not asking us to do that right now, okay? So what is the mass of the salt and pepper mixture? 6,500. And what's my label? Look up here. What was on the scale? Gram. Step it out. Number 2. A wallaby jumps 7/10 meter. Then it jumps 1/1800 meter. How far does the wallaby jump after jumping twice? Write an equation to model the problem. Use J for the distance the wallaby jumps after jumping twice. So let's pull out our information that we have. Okay, so are we adding, subtracting, multiplying, or dividing? Adding. So we're going to do 7/10 plus 1,800 equals J for how far they jumped after both jumps, right? Okay. Letter B, reading 7/10 is a fraction with a denominator of 100. So what's my new denominator? 100, right? Okay, so I'm going to draw my fraction bar and write 100 on the bottom. Then I'm going to do my looping, so I have to show some work, right? How did I get from 10 to 100? Times 10. And what I do on the bottom, I have to do on the top. 7 times 10 is 70. So now our fraction of 7/10 is now going to be 70 hundredths, right? Okay, so we're going to replace that. So 70 hundredths plus 1,800 equals, what is 70 plus 18? 80 what? 8,800. So how far does the wallaby jump after jumping twice? 8,800 meter. So 8,800 meter. Check understanding number 1. Molly has 3/10 of a pound of red clay and 6,300 pounds of gray clay. How many pounds of clay does she have? So we're going to pull out 3/10 of a pound, 63/100 of a pound. How many pounds of clay does she have? So are we adding, subtracting, multiplying, or dividing? We're going to add, okay? But can I just go ahead and add 3/10 plus 63/100? No, because they do not have a what? A common denominator. So we need to get a common denominator. So we need to put 3/10 equals what? What's going to be our new denominator? 100 on the bottom. So how did I get from 10 to 100? Times 10. What I do on the bottom, I have to do on the top. So 3 times 10 is 30. So now what am I going to do?
Add 63.
So 30/100 plus 63/100. Now can I add those together?
Yes.
Yes, because they have a what? A common denominator. So what is 30 plus 63? 93/100. And what's my label? Pound. On number 2, I have 41/100 plus 1/10. Can I go ahead and add them? No. Why not? Because I have to have a common denominator. So what would 1/10 also equal? I'd have 100 as my new denominator, correct? Okay. How did I get from 10 to 100? Times 10. What I do on the bottom, I do on the top. So what is 1 times 10? 10. Now can I add them together? Yeah. So 41/100 plus 10/100 is what? 51/100. Now, I was able to fit that there. If I don't have enough room, what should I probably get? An extra paper. Or extra sheet of paper. Because if you're trying to stuff it in there and you can't read it, then is that helping you? No. Number 3, I have 8/10 plus 15/100. Can I go ahead and add them? No, because I don't have a what? Common denominator. So I'm going to have to change which one? 8/10. So I need my new denominator to be 100, correct? Okay. So how did I get from 10 to 100? Times 10. What I do on the bottom, I do on the top. So it is 8 times 10. 80. Now can I add them?
Yes.
Yep. So 80/100 plus 15/100 gives me 95/100. Okay. 2/10 plus 67/100. Can I go ahead and add those? No, because they don't have a what? Common denominator. What does our common denominator need to be? 100. So I need to change 2/10. So how did I get from 10 to 100? Times 10. What I do on the bottom, I do on the top. So 2 times 10 is 20. So now can I add them?
Yes.
Yes, because I have a common denominator. So 20/100 plus 67/100 gives me 87/100. Number 5, 33/100 plus 3/10. Can I add those together? No, because they do not have a what? Common denominator. So I need to get 100 as my common denominator, so I need to change 3/10. So how did I get from 10 to 100? What I do on the bottom, I do on the top. 3 times 10 is 30. Now can I add those together? Yes. So 33/100 plus 30/100 is
63.
On your own. Number 6, attend to precision. Daniel collects rocks. What is the total mass of the piece of quartz and the piece of obsidian? So you can use the hundreds model to help you rename 5/10 as a fraction with a denominator of 100. Model the problem with an equation. Let n equal the total mass of the two rocks. find the value of M. Okay, so we would do what? 2,700 plus 5/10 equals the mass of both rocks. So 5/10, is this in tenths or is this in hundreds? Hundreds. Okay, so if I was going to do 5/10, how many longs would I color in? I color in what? 5, right? Okay, so if I color it in 5 longs, how much is that of the hundredths cube? 50, right? Okay, so I'm going to rewrite this as 2,700 plus 50/100 equals, what is 2,700 plus 50/100? 7,700 of a what? Kilogram. Number 7, model with mathematics. Keisha pours 9/10 liter of orange juice into a jug. Then she pours 8/100 liter of lemon juice into the jug. How much juice is in the jug? Okay, so can we add those two together yet? No, because do we have a common denominator? No. So we have to rename 9/10, correct? Yeah. Okay, so how did I get from 10 to 100? Times 10. So what I do on the bottom, I do on the top. So 9 times 10 is 90. So now I have 90 hundredths plus 8 hundredths equals J for the value of the juice, right? Okay, so what is 90 plus 8?
98.
So 98 hundredths of a liter.